Welcome to myprojectbazaar.com. Let we discuss about the process and explicit shape constraint MRF based contour evaluation method for 2D medical image segmentation. Let us see the abstract of the process. Segmentation is an important task in all kinds of image analysis. In medical image analysis, segmentation has a great clinical value since the aim could be to localize the organs or pathologies in order to raise the quality of the diagnosis. The segmentation of the images has numerous applications in computer vision and other artificial intelligence process. The important non-contrast CT images of heart were taken as input. The input images were segmented using 4 different models in order to obtain the overall segmentation of the heart image with minimized energy. The first step in any energy minimization problem is the identification of the energy function. The boundary, region, and shape energy terms were used in this process. Boundary terms are concerned with the object boundary regions, the region outside or inside the object. The shape term relates the shape of the object, and the other energy terms include spatial constraints on multipath objects, for example, layers, exclusions, or labels. As expected, all functions must have domains, and so in turn energy functionals must have domains. The domain is the space of the possible segmentation of the image shapes. There are many different ways to represent the underlying segmentation. That choice in turn impacts the image and shape terms that can be readily evaluated. A substantial amount of knowledge is often available about anatomical structures of interest, characteristic shapes, positions or orientations, symmetry relationships to the neighboring structures, associated landmarks, about the plausible image intensity characteristics subject to natural biological variability, and date shapes of periods. The shape periods have been a particular area of interest selection. Linear shape models assumes that the data lies on a linear manifold, but the shapes often lies on nonlinear manifolds where the manifold's properties are not accurately captured by linear statistics. The input images were segmented using 4 different models that were based on boundary, edge, shape, period models. The segmentation energy is measured in each case. The final segmentation energy is measured by combination of the segmentation energy of all the obtained energy in each segmentation cases. The iterations were repeated so that the segmentation energy is minimized compared to the segmentation energy obtained in the previous iteration. Let us see the flow of the process. First, the input image is obtained. The energy value of the input image is calculated. So we train the system by saving the energy values previously in the database, so that trained energy values and the distance between the trained energy values and the input features input image energy value is calculated. So the distance with which it is matching, based on that the control points of the input image and the shape of the input image were extracted. The control points it denotes the overall outer edges of the required organ region in the input image, and the registered shape denotes the complete pixels which are all present in the needed region of interest, which is manually saved previously for each images in the dataset. So for which it is matching, the data scanner So these control points were given as input for the shape real segmentation models. So in the shape real models, the input shapes were plotted in the original images and it is grown so that it obtains the origin regions very exactly. After that, the appearance prior model is employed. So the appearance prior model identifies the then appearance prior model is employed. In appearance prior model, the identified regions were grown in the process and overall background region and the foreground regions were extracted. And after that, the boundary edges prior. So in the boundary edges prior and in the label regularization prior, the overall segmentation is employed based on the analysis of the Markov random model and the finding of the segmentation energy at each of the cases, and from that overall segmentation energy in each of the cases were identified. So this identified segmentation energy is checked to be minimum. So if the segmentation energy is minimum means then the process ends, or else the process is repeated again by giving input the shape obtained at this stage to the shape pre-segmentation model. So this is the overall execution of the process starting from the selection of the image up to the final segmentation of the image. Let us see the running procedure of the process. If you want to run the code, select the file main.m which is located on the source code folder. If you select the file main.m, right click it and click on run file, you will get the process started. So first the input images will be displayed, so we can select any one of the images which is present here. Since we have given labels for the images that we have presented here, so the process will work for these 4 images alone. So first the input images is selected. Initially, the control points were extracted for the input images, and based on that, the contour registered shape is obtained by matching the input shapes with the regions, and based on that, the registration process is employed, and after that, the registered shapes were obtained. Based on that, contour is extracted. This contour is given as input for the appearance prior model. So as we can see, based on the iterations, the foreground and the background regions were separating. So after the separation of the foreground and the background, the next process will move. This process will take some time for the complete execution since it runs in iterations. So after the completion of the iterations, the segmentation process is done. So as we can see, after the completion of the iteration, the foreground and the background regions were separated. So this regions contains the organs, tissues, everything. And after that, this is the exact the results displayed here. This is the foreground regions and this is the background regions that we have extracted. Then after the completion of this processes, we calculate the label regularization period and the energy minimized segmentation. So first based on that, the MRI cliché graph is extracted for the input images. After the extraction of the cliché graph, the label regularized segmentation and the energy minimized segmentations were applied, and this is the final result that we got. And while segmentation of the process, this is the final energy minimized segmentation of the input images that we obtained. So finally, this is the energy minimized segmentation. So here we are representing the organ in one color and the background regions in another color representation. Thus, we have calculated the minimized energy segmented regions from the overall images. So we have extracted exactly the organ regions, even though the other regions were all presented in the input images. Thank you.